All right, try that one. Thumbs up when you have an answer. Have a conversation without your phones. So weight is one example of a force. So this is like a general category. This is a specific example. It's like, this would be dog. This would be like a Dalmatian. Like this is a general category. And this is one example of a force. So they're both going to be measured in newtons. So what's the letter? Variable. Don't worry about it. Okay, correct answer is A. Okay, the pattern is if you are launching at complementary angles at the same velocity, you're going to have the same range. That make sense? Okay, based on your lab. Next question.
Okay. On this one, I want to make sure that I hit all my vertical and horizontal information.
When does that happen?
Whenever it hits.
No, has not hit.
Okay.
Because that would be free fall.
Okay.
Sorry, that would not be free fall.
Oh, because it goes down at the same speed that it
yeah.
Okay. For my equation, I need to find time, so then I use this.
Yep.
And then after I use that, I use this.
In which direction?
This would be negative direction, right?
Horizontal or vertical.
Oh, okay. So that would be.
Work through it and see what happens.
When looking for the what is this?
The range, the delta,
yeah.
Horizontal displacement.
Horizontal.
Tell your neighbor.
Which is 13.6. Final. I would have to find final first, right? So I would have to use a different equation to find final velocity for horizontal. And then
So in the horizontal direction, how would you describe what happens to the velocity as time goes on? So your initial and your final are
the
same.
Okay, yeah, I was thinking that, but no, so they're both 13.6. Right?
Yep. Okay, correct answer is A. Is that what your lab said? Okay. The one that goes higher is in the air for longer. Good with that? Okay.
did something wrong there, didn't I?
Alright, you bring this over here first.
Oh, yeah, because that's connected to the variable.
I'll just solve for x. Gravity's still a thing. Yep, we're on Earth. No.
No.
Because when you take -4 minus 4,
that's 8 over 3.
yeah, -8 over 3. Okay, we're going to assume that this isn't a gun. It's just a launcher. So it doesn't go like crazy fast. Have a conversation. Right.
Correct. And I can just use this equation to find out.
What did you do?
To get that.
What did you do?
Oh, I use this right here.
Oh, that was just a math problem.
Oh, I thought you were saying.
No, that was just to show you. Correct answer is B. You need to shoot above it because it's going to be lobbed, right? It's going to drop below. Okay? Are we good? Okay. Next question. Where are you coming from? Listen. Listen. Remember? Okay, what do you say? Hey, it's what we did yesterday, right? Okay. Everybody good with that? Shooting the monkey? Whoa. Good with that? All right, so I'm going to modify that. What would happen if we shot it slower? Have a conversation.
So I did this all with my vertical information.
Yep.
So that's what I got for my time, and that's what I got for my change.
Okay. For your what?
For my change of distance, like my.
Is that horizontal or vertical?
Vertical.
Okay.
So that would be how high I went, correct?
Okay. When can you use this equation?
Whenever acceleration is not involved.
Right. And the vertical direction is acceleration involved?
Yes.
Yes. So that doesn't work in the vertical direction.
Okay, only horizontal direction.
Right.
Okay. So what do I need to do to find how high I went then?
Okay. Fix this for horizontal.
Okay.
Like what would you do different?
I would just plug in my, I would just do plug this information in, pull up my time here, and then put it into there. I just do this equation, but for my horizontal, right?
Okay. That.
That should be negative 22.98, shouldn't it?
How would you describe what happens in the horizontal direction to the velocity?
Oh, it just stays the same.
So this would be 22.98.
When I'm looking for height, that would be this for vertical.
Delta Y, yep.
So I'm looking for that for vertical.
So then, do I just plug my vertical information or my horizontal information into this equation and then put it into this equation? Find time and my how far out.
Go ahead and don't do it, but just try it and see what happens. Like, see what you get.
Because I think it's going to cancel out. Because it's 22.9.
Right, so you can use this to find time.
Okay.
And then you're going to use this equation for the horizontal with the time. Okay. We're going to see if you're right.
Are we shooting something?
Yeah, we are. Okay, so.
Is that our monkey again?
Yep.
Why can't we get an actual monkey?
Lots of reasons.
Wait a second.
On that metal sheet.
Oh, he's cute. Let's kill him.
Yeah, let's kill
He's
him.
like a demon monkey.
I love demons.
We need to, like, kill it.
I bet you it's gonna remain the same. Why do that?
Okay, so we're going to put it. Anybody want to verify that I'm aiming right at it? Yeah, I got a crosshairs. Come on, Devin. Okay, watch your head when you come out.
Yeah, you're aiming at it. Right above its forehead.
Okay. So 3 clicks. Or I might get it better. Oh, it's all in there. Nice. Okay, 3 clicks. Ready? 3, 2, 1.
Hey, that was a nice flag.
It was. Okay. So now what we're going to do is we're going to do it at 2 clicks. I'm going to keep it at the same angle, and we're going to see if we hit it or not. Does that make sense?
Yeah.
We'll get there. Here's 2 clicks. 3, 2, 1. Get it? Nailed it. Okay. Now, what about 1 click? Three, 2, 1. Didn't hit it. It hit the ground before it hit the monkey. Now, let's say we did it on. Let's say we did it on a balcony. And the edge of the balcony was here, and the monkey fell, and the ball didn't hit the balcony. Would the monkey get hit?
Yeah.
Hmm. So, do we have this conversation? I think we're running out of time. Why are real guns different?
Don't real guns like have some circular?
There is some rifling. So, like, it makes the bullet do a spiral. I could throw a spiral football. Okay. But, lose power. That just makes it a little more aerodynamic. That does not. That wouldn't allow it to float. That just allows it to sail through the air better. Does that make sense? So what else? How are real guns different? Okay, they go faster speed, so the time in the air isn't that long. So it doesn't drop that much. What else? There's one other reason.
Bullets are more aerodynamic.
That's true, but that just enables it to cut through the air. It doesn't necessarily allow it to lift. On sniper movies, when they're going for long distances, what are they looking? Like, they're adjusting their scope to compensate. They actually lob the bullet like a football over long distances. Good with that? So they're adjusting for the distance. So the longer it is, the more they're ending up pointing their gun up. Cool with that? Okay.
You probably got up here and you're looking at the barrel through your scope. I know what you don't know how scope works? They don't know how scopes work. Just explain that.
Yeah, guys,
That's not how that works. You don't move the actual scope.
I know, that's what I'm saying, yes.
The reticles compensate for the wind bullet drop.
I think we're all agreeing. I don't know if we're necessarily disagreeing.
I agree to disagree.
I think that's it. My mom says that every time I'm right, she just says agree to disagree. So
All right, give this one a shot.
A. You can't do that. A.
Talk to your neighbor.
A.
Alright. So now that I have my time, change it.
So this is for 40. So fill in this. Like that goes there, that goes there. This goes here.
Oh wait, what goes? You said 30 meters per second
No.
going the initial. So 22.9 goes here. 19.3 goes there.
Does that make sense?
Yeah. Just so I know for future.
That goes there. That goes there.
Okay, and then how do I calculate height?
What do you know happens at the highest point?
It's at the slowest point that it's going.
Right. And vertically, what happens?
It stops.
Right. So vertically, at the highest point, it's going 0.
Okay.
And then you can solve for delta y. And just change the delta x to delta y.
Here.
Not here. When can you? Can
Whenever
you,
acceleration is not involved.
right.
Whenever the acceleration is involved.
Right.
So would I be using this?
Maybe. Maybe.
Maybe.
Maybe.
But most likely not.
It depends if you apply it right. Depends if you apply it correctly. Okay, correct answer is? Hey, is everybody good with that? Like, that makes sense based on your lab? The higher it goes, the faster its vertical velocity. Okay. All right. Next question. Next question.
When I am plugging this in, I'm not getting this. I'm getting like every other number but that. I'm plugging them in right. So I chose this one. I can't do because this is negative 6.3 times the negative 6.3.
Where's the ball at 1.3 seconds?
It's 0.8 seconds. Or wait, 0.3. 0.3. Oh. I think I do. Oh, I actually put 1.6 divided by 2. I actually put the wrong number because it was my old number. Okay, so I think that's
Foxtrot. Gamma.
Everybody have a guess on this one? Have a conversation.
I'm thinking this one's not the right one to use because I would just cancel out to delta y equals 3.98, correct?
Okay, so where are you saying your final is?
What do you mean? My final velocity?
Your final position. Yeah.
It'd be negative 19.3.
Where are you looking to find the height, maximum height? Where on this trajectory?
Right here.
Right. So your velocity at that point
would be 0.
Right.
November, that's what it is. November, Papa. Oh,
It's when it enters
Imagine
the
that.
takes less time. So if it's
Okay,
extended
and then just
time,
multiply that by half by 3.98.
it's probably
So
the
it's-
same amount of time.
Alpha, Beta,
So like
Charlie,
you have to
Delta,
move a lot
Echo,
more.
Foxtrot. Gamma, Oscar.
Okay, what do you say? Okay. So here is a different way to look at it. Like I heard a lot of letters. It's not D. Here's my suggestion. Look at half this. Pretend there are balconies or a building. And just look at half the flight. Starting at the top. So I don't really care about how fast is going vertically here. 0. So is it moving here? Which way is it moving? Horizontally. Certain speed. Same thing here, right? Which one's faster horizontal? A or B? Is everybody okay with B being faster? Okay. So B is also going horizontal, but it's going faster. If we threw both of these balls simultaneously, both horizontally, this one's slower than this one, This one higher than this one. Which one's going to hit the ground first? Tell your neighbor and tell them why. Which one's going to hit the ground first? Okay. Yeah. Good. What I want you to do is I want you to read this question and write the letter, the variable, above the unit. So, so what is that? A variable of?
M.
Just write M above that. Okay. 6. Yep. So right. Yep. And then what are you looking for?
N. No, A.
So what is? Sorry, no, that's capital A. Or sorry, capital F. Okay. Which one's going to hit the ground first? All right, let me break it down a little easier. If I drop the black marker from here and the green marker from here, which one's going to hit the ground first? Why the green? Closer to the ground. Has less distance to fall. Which one's going to hit the ground first? B is going to hit the ground first because they're both of them have an initial vertical velocity of 0. Vertically, as if they are both dropped. It's moving horizontally, yes, but does the horizontal motion affect the vertical? No, it's independent. How are we doing with that? So is everybody all right with B is going to hit the ground first, regardless of how fast it's going horizontally? Now, the time up equals the time down. Time up equals the time down. So if it takes longer for this to come down, it's going to take longer for this to go up and down compared to this up and down. B gets hit first. Good with that? Based on how high it went. How are we doing? Okay. Last question. What are you looking for? So you're going to do this. You're going to say, that's what you're looking for. So you just do this with a number. So this is the force. So I'm just going to do force. Okay, what are you looking for? Have a conversation. Tell them why.
Okay. Just want to make sure that this looks right. My height.
If you don't know what the difference between come on, Mike Elka.
Oh, I
Mike Elka.
Come on, Mike Echo Romeo Echo Delta India Tango Hotel. Come on.
What were you doing? Oh, we did do that. Where is it at 3.94 seconds?
Oh, it'd only be halfway. So I'd have to catch it.
Yeah. Okay, what do you say?
I want to say C.
Like dangerous dinosaurs?
C.
If you stretch it up, I feel like the A would
Apparently we're not doing well based
Oh.
on that look.
Elephants.
A.
Papa. C.
Okay.
Papa.
Look at half of the, like, cut it in half. Cut it in half. Same.
But there's no different initial velocities. They like.
Okay, so if I took this and I launched one of them and then launched another one at the same time, just faster, which one's going to hit the ground first? Just as if I dropped one.
I was right. Let's go. I'm not totally.
Get rid of that. Okay, here's a follow-up question. On this previous question, were these complementary angles? You're launching at the same velocity. Were these complementary angles? Tell your neighbor why or why not. Okay. Now, which equation would you pick? Was this, and this? Yep. So write that equation.
Yankee Echo.
Okay. Complementary, yes or no? No. They had different ranges. Which one's closer to 45? Which is close? A or B is closer to 45? Have a conversation. Tell them why. Which one's closer to 45? And then plug in your numbers. No, just plug in your numbers. And then do the math.
That is closer to that.
Does that look better? 18.95 was my results.
Looks a lot better. Welcome. Okay. Which one's closer to 45?
None of them.
Okay, why am I picking 45 degrees?
Middle point.
That's your maximum range. Okay? The one, so 45 is going to be somewhere over here. B got closer to that than A did. Does that make sense? Okay. Correct answer is B. All right.